Hello, welcome back to Breault Research Organization's Apex Introductory Tutorial. My name is Rob Purcell, and today we will be going over Practice Session 1. We will apply the 4-step workflow to design and analyze this system, which includes a parabolic reflector and a target. So for this one, I won't be showing every slide one at a time, but we will be going through them while I show the content in them. So feel free to follow along if you want, or you can just watch the video. Well, the first step in the 4-step process, if you remember, is design and verify the geometry. So here is the specifications of our geometry that we will be building momentarily. Okay, first things first, before we even do anything, we're going to want to go to our desktop and create a folder, new folder, that we will call apex_intro. This is the folder we will use for all of our files for this example. After we've created this file, you're going to want to go ahead and open up SolidWorks. Alright, now that you have SolidWorks open, the first thing you're going to want to do is verify that Apex is installed and active, because you're going to need it for this example. So you're going to go up to this drop-down arrow and click Add-ins. Then you're going to scroll down and make sure that Apex right here is installed and active. Once you've done that, you're going to go up here to New and press New. This will be the default new screen, and what you're going to want to do is press Advanced, and then typically you'll be here, but you'll go over to the Apex tab, and for our example, we're going to be using the millimeter ISO part. You'll click that and press OK. Alright, now that our part file is open, the first thing we're going to need to do is create a sketch. This is how most part files start. So you're going to go to the Sketch tab if you're not already there, click Sketch. For our example, we will be on the right plane, so click that. The view will automatically focus on the right plane. Now that our sketch is on the right plane, what we need to do is go over to the ellipse button, click the drop down, click parabola. You're going to want to put the vertex at the origin, and then move it to the right. As of right now, the size doesn't matter yet. We will figure that out momentarily, but let's put it there. And then you need to click again to draw a little arc, and then just click again to solidify it. Again, size doesn't matter yet. We'll figure that out in a sec. And then once you have something that looks a little like this, you just press OK. So the first relation we will set, we'll go up here to display delete relations. We'll click add relation. You want to make sure you have nothing selected right now. And then what you need is the origin and the vertex here, and you're going to click horizontal, so that way our parabola stays on axis. Alright, now that our relation is set, we're going to want to set the size of our focal length, so you're going to click Smart Dimension, and then click the origin and the vertex. We're going to set that to a size of 2 millimeters. And it'll adjust for us. Next, we want to make sure our opening is big enough for the light source. So you're going to want to click Smart Dimension again, click the origin and the bottom of our arc, and set that to a distance of 4. Then finally, what you're going to want to do is click the 2 endpoints of the arc to set the length of the parabola to 75. There you go. As you see, our sketch is all distanced out, and down here it says we are fully defined. Next, now that we have our fully defined sketch, what we want to do is turn it into a physical object. So first what we need to do is go up here to Line, and establish a center line as a reference point. To make it easy on ourselves, I'm going to click horizontal and infinite length, and then just place it at the origin. Great, confirm that. So now we have a reference line. Real quick, we're going to save this part, to our folder that we made on the desktop. We will call it base parabola, and we will potentially use it in the future, and it's a good starting point. So save that real quick. So after we've saved it, we're going to establish the surface. So you're going to want to go to the Surfaces tab, which should be right next to Sketch. If you don't have it, right-click on any of these tabs and go to Tabs, and Surfaces will be right here. You'll just turn it on. What we want is a revolved surface. It should automatically set it up, but if it doesn't, your axis of revolution will be this line, and you'll want it fully 360 degrees. You'll confirm. So now we have our parabola. Click so we remember. You're going to go over here to the tree, right click on this, and click Feature Properties. We will call this the reflector, since that's what it is. You write a little short description, right? Parabolic reflector. And then we will press OK. So now over here it says reflector, so we know that that's what it's referring to. Thing we need to do before we're done with this part, and expand this out here, we're going to want to go over to the Apex Optics Manager and right click on Base Parabola, press Set Coding. Then we're going to go to Ideal Coding and Reflecting. We want Perfectly Reflecting, and press OK. What this does is make our reflector an actually reflecting surface. So then what we can finally do is go up here and press Save As. We want to call this Reflector. You can add a description if you would like. Apex Intro Reflector. And then we're going to press Save. So now we have our first part completely done. What you want to do is minimize it. Now the first part is completed. It should be on this slide, where we will be going into building the next part. SolidWorks. First thing we're going to need to do is go up here to New, create a new part file. We're going to do another millimeter ISO file, press OK. That's up just like before. You're going to go to Sketch and create a new sketch. We're going to put this one on the front plane this time. You're going to go up here to Rectangle, Center Rectangle. You want to center it at the origin, and you want our shape. Size doesn't matter just yet. We're going to do that in a sec. But once you've confirmed it, press OK. Now we want our detector to be a square. So to make it so, you're going to want to press Smart Dimension, click one of the sides, and set it to a length of 100. And then what you want to do is click one of the opposite sides, click 100 as well. And you should have a fully defined square shape. There are different ways you could have done that. You could have done relations and set them equal to each other, or used an equation, but all of the different ways work. Either way, now that we have our shape, what we want to do is go to Features, and we want Extruded Boss Base. 10 millimeters is fine. Should be the default. And we're going to confirm that. Now we have a 3-dimensional square surface. And then, just like last time, what we want to do is right-click here, click Feature Properties, and we want to call this the target. We can confirm that. So now we have our target. Afterwards, we want to go over to the Apex Optics Manager again. We will click this and click Set Coding. We'll again do an ideal coding, but this time what we want is absorbing, perfectly absorbing. Click OK. Now our target will absorb the light. Finally, we can save this part. We can call it target. Confirm that. There's our second part, which now that we're done with, we can minimize. We have both part files done. The next step in designing and verifying the geometry is combining them into an assembly file. So what we'll do is go up here to New. What we want this time is assembly millimeter ISO right here. We will open that. In our assembly, you can see here are our part files that we left open. What we want to do first is select the reflector. And we just want to click the check mark and it'll just put it automatically at the origin. So now that our reflector is in here, what we want to do is go up to View and click Left. So over here, you see this little F next to our reflector. That means fixed, means our reflector can't move. And since this is where we want it, we are going to keep it fixed. Next, what we want to do is go to the Assembly tab and click Insert Components. And now we want to put our target in there. We just kind of want to put it somewhere over here to the side. If you notice, this doesn't have the F. This means that our target is not fixed. We can move it around, but we want to define it because, as you can see down here, we are underdefined with it not being fixed. What we will do to define it is go over here to Mate. Mates are kind of similar to smart dimensions, but for assemblies. The way we will assign these mates, do the easier ones first. First, what we want to do is click these drop-down arrows next to our parts. What we want is the top plane of the reflector and the top plane of the target. We want them to be coincident. So there's one mate, and click OK. Next, we want the right plane of the reflector and the right plane of the target to be coincident. That's okay. And then finally, we want the front plane of the reflector and the front plane of the target. We want these to be a distance of 250 millimeters from each other. Then we can click OK. So now, as you can see, we are fully defined. Now we can close out of this. We can save this. We can call it Illuminator. And we can save our assembly. And this is it for step 1, designing and verifying the geometry. Next, we can move on to step 2, design and verify the sources. Here are the specs for the specific source we will be using for our design. Back in our assembly file, the first thing we want to do is go over to the Sources tab and click Manage Sources. The source we want is an LED. We will scroll down to find it. It is LW3C right here. We will click Insert. Then what we want to do is create a ray set. So we will create a new ray set, press Next. We want single wavelength with 100,000 rays. We want a wavelength of 550 nanometers. With that changed, we press Finish. We'll generate a ray set and insert our source into the geometry. Zooming in, you can right-click on our reflector and click Change Transparency, which is up here. Then we can see the source. And if you look closely, you can see it's not exactly where we want it. what we're going to want to do is move the source back a little bit, and then we're going to mate it like we would any other geometry. Go ahead and click mate. What you want is this surface right here, and this edge right here, and then we click OK. Since it's still obviously off, is we're going to make the planes like we did earlier. So we'll open up the source. We want the top plane with the top plane of the assembly, and then we want the right plane of the source with the right plane of the assembly. Now our source should be properly aligned. So we can close out of this, and if you look, our system is fully defined, so we can then go ahead and save the assembly. Now that the source is set up, we're going to verify it. So the first thing we want to do is go over here and click this, and then we want all statistics. This gives us a nice little overview. This is the data we're looking for. The flux seems to be good. So we can kind of move on from there. If we wanted to go back to it, it stays here on the Optics Manager, which is nice. But let's then visualize it. So we'll go up here and click Radiant Intensity Cosine. We want conversion angle space, and we want the data resolution to be 91. We want it to be on the XY plane. When we confirm that, this gives us a nice little plot. We have two different radiant intensity plots. So what we want to go ahead and do is right click this and click Process Dataset. We want to average it out. Click OK. Then what we want to do with the average, to visualize it, make sure average is selected. Then over here, expand, we want to click Picture Plot. This gives us a nice average picture plot of our source. And finally, we also want to average out the angles data. So we'll right click that and click Process Dataset there. Average this one out. And once again, do a picture plot. Here's our average angle data. This is kind of what we're looking for. As you can see, the reflector is focusing most of the source. So our source has been verified properly. So we can go ahead and save this. Next, we can move on to step 3, trace the rays. Back in the assembly, first thing you're going to want to do is go up here to Project Settings and click All Settings to open up the Settings menu. Now the main things we need to check are the ambient medium. We want to make sure it's air. And then under wavelength and power, we want to make sure that power units are set to lumens. Then you want to go down to Ray Trace Display, and we want to select Display Nth Ray, where N is 1000. And then we're going to set the trace color to just a more noticeable color. I'm going to pick red. And then we want to go to Ray Arrows and Mist Rays. And we want to make sure the distance to extend rays in 3D is 250. And we can press OK. Once those are saved, go back to the Trace tab. We're just going to press Trace Rays. Now we have rays traced in our system. After this, if you want, you can go over to this tab, the Apex Optics Manager, right-click on the ray trace that's down here and press Hide Show Information. And you can find information about the different rays, how long the trace took. That is all we need to do for step 3, trace the rays. Now we can move on to step 4, perform analysis. We will be performing the following analyses on our system. In our assembly, with our ray trace selected and visible, we want to go up here and click Summary Statistics. This gives us a nice summary of all of our data. Then what we want to do is click the face of the target and click Radiance. The plots we want are all of them. We want to see all of them. And then we want to change the data resolution to 91. Once that's changed, we can go ahead and confirm. This will give us the different plots. Now that we have both the spots and a radiance plot, we can go ahead and click this result set, right-click it, and process it. We will average it out like we've done before. And with this new average, we can make both a picture plot and a contour graph. Next, we can go ahead and make an intensity plot. So we'll go back to our ray trace, click the front surface again, and click radiant intensity. We want both these and a data resolution of 91 again. We can confirm that. If we wanted it to be even more focused, we can go back and do it again, but with a smaller range. So I'll do 0.2, negative 0.2. And confirm that. We have a more focused plot. If you don't want to enter that manually, you can go back and click it again, and you can click automatic, and it will automatically generate a plot that's focused and zoomed in. And then just like before, we want to right click on result set intensity. We can process this. We can once again do the average. From the average, we can then make both a picture plot and a contour if we want. So we have all this data at our fingertips. And with that, we have now finished all 4 steps of our 4-step process and finished practice session 1.